Dear learner, I welcome you all to the MOOC on renewable energy technologies and their uses. I am Dr. Sanjay Agrawal, Associate Professor in Electrical Engineering, School of Engineering and Technology, Indira Gandhi National Open University, New Delhi. Dear learner, in this particular session, we will discuss sizing of the photovoltaic system, means how we have to design or how you have to decide the size of any photovoltaic system on the basis of given electrical load. Like suppose you are going to install any photovoltaic system for your house, that means you need to know what is the electrical load of that particular house. Then you can also decide the sizing of the photovoltaic system. After that, we will also discuss different terminology like solar cells, or you can say photovoltaic cells. What is the photovoltaic modules, what is a photovoltaic panel or arrays. And after that, we will also discuss how you can classify different PV system. That means PV system can be classified as grid connected or utility interactive PV system. Then you can also classify it as standalone PV system. It can also be classified as hybrid PV system. So hybrid PV system means what? That means it is a mix of two systems. Like suppose you are mixing this system with solar as well as wind, or you can also integrate with the diesel generator. So there is a mixing of all these hybrid PV, wind, diesel, then it will be called hybrid PV system. So as you know, photovoltaic is the technology for conversion of solar radiation directly into electricity. It has already been discussed in the previous lecture. A photovoltaic cell, also called a PV or solar cell, is the device used for this purpose. Solar cells are generally made of high purity silicon wafers. Several materials such as silicon thin film, gallium arsenide, cadmium telluride, copper indium diselenide, etc. are also used to make solar cells. Now we will discuss how the sizing of photovoltaic system is decided. The application of solar PV technology are increasing very rapidly. At present, following three areas are gaining importance. What is that? First one is domestic application. In domestic application, you can see as a home light, street light and community light. Second area is agricultural sector, that is for the lift irrigation, and third one is power generation. For making solar PV system, you need to know following things. First one is the energy to be used by the appliances under consideration. Second, the energy storage capacity of the battery. Third one is the energy to be used for appliances under consideration. Then you have to know the size of the solar PV system. Now we have to see energy to be used for applications under consideration. So what you have to do? The rating of all electricity using appliances are given in watts. Like suppose you are using any CFL, so the rating of that CFL is 18 watt CFL, or suppose you are using any ceiling fan, so it will consume approximate 40 watt electricity. If you are using any suppose a refrigerator, so it will also consume around 80 watt or 100 watt. So it depends on the wattage capacity of any appliances. You can compute the energy consumed by simply multiplying the power rating by the hours of the use. For example, a 18 CFL, if used for 5 hours, is going to consume 18 into 5, that is 90 watt hour from the battery. In a similar way, you can work out the total energy requirement. Now we have to decide storage capacity of the battery. The storage capacity of battery is measured in ampere hour, that is like 20 ampere hour. That means, what is meaning of this 20 ampere hour? That means this battery can give 20 ampere if you are using it for 1 hour. Suppose you are using this battery for 2 hours, that means it can give the 10 ampere power. If this value of ampere hour is multiplied by the battery voltage, for example 12 volt, you will get watt hour. Thus, for current case, we get 20 ampere hour multiplied by 12 volt, that is 240 ampere volt hour, that is 240 watt hour. This simply means that battery is able to supply 240 watt for 1 hour or 120 watt for 2 hours, 80 watt for 3 hours. In other words, if more energy is taken from the battery, it will discharge faster. Now, we have to see the size of the solar PV system. For calculating energy which can be supplied by the solar cell panel, you need to adopt the following procedure. Multiply the wattage of the solar panel by the hours of the sunshine available. And how you will measure the sunshine hours? It will depends on the weather or climate. Like suppose you are talking about the daily climatic condition, that means it is approximately sunshine hour for during the summer, it is approximately 9 to 10 hours. Then results so obtained by multiplied by a factor of 0.85 to account for the additional losses. Thus, for 15 watt panel, 6 hours of the sunshine, the energy supplied will be 15 into 6 multiplied by 0.85. So it comes 76.5 watt hour. Now we can take one example. During night hour, suppose you wish to use a light bulb, that is CFL, and fan for 3 hours. So the total wattage of CFL and fan is 60 watt. So you have to determine the size of the battery. So how you will decide the size of the battery? So total watt hour required is 60 watt multiplied by 3 hours. It comes 180 watt hour. So if you decide to buy a 12 volt battery, its ampere hour rating will be 180 watt hour divided by 12 volts. So it comes 15 ampere hour. So for 6 volt battery, the ampere hour will be 180 watt hour divided by 6 volt. So it comes 30 ampere hour. Now we have to understand different terminology like photovoltaic cells, modules, what is arrays. So as you know, you have learned that solar PV devices use semiconducting material to convert sunlight directly into electricity. The current produced by a single solar cell is not enough to run electrical equipment. In order to increase their utility, our solar PV cells are arranged in particular sequence as shown in the figure. So solar cell is basically a smallest unit of a system are connected and packaged together in solar modules. Multiple modules are connected in series and parallel combination into an array. So here you can see in the diagram. So smallest unit is a cell. Here you can see. Then different solars are connected in some manner. It may be in a series or in parallel. So it is called PV module. So basically whenever you see one plate, that is basically called PV module. So the rating of the different module may be the different. Suppose I am talking that output voltage, or you can say open circuit voltage of one solar cell is 0.5 volt and current is 4.4 ampere. So here you can see in the module, here 9 solar cells are connected in series. So what will be the output voltage or open circuit voltage of one module is 9 into 0.5. And because all cells are connected in series, so current will be the same, 4.4 ampere. Now all these PV modules are connected in some manner. It may be connected in series or it may be connected in the parallel. So combination of different PV modules are called PV array. Now suppose you have to decide what should be the size of the array. So basically it depends on the load, right? Suppose I am assuming that output of, or you can say open circuit voltage of one PV module is 100 volt, right? And you require 230 volt. So what you will do? 230 divided by 100. So it comes 2.3. That means you need approximately 2.3 modules. So you cannot take 2.3 module. That means you need approximately 3 modules which will be connected in series. So in brief, you can say smallest unit of solar cell is called solar cell. If solar cells are connected in some manner, it will be called PV module. If different PV modules are connected in some manner, either in series or in parallel, then it will be called PV array. Now, again we will understand what is PV module. When many individual PV cells are interconnected together in a sealed package, it is called module. The current and voltage are governed by the following norms. What are those norms? When two modules are connected together in series, their voltage is doubled while the current remains constant. As I already told you that if you are connected in series, the current will be the same and voltage will be added. And when two modules are connected in the parallel, their current is doubled while the voltage remains the constant. Now, again we will understand what is a PV array. So, in order to achieve desired voltage and current, modules are interconnected in series and parallel combination, which is called PV array. This type of flexibility of PV system allows us to create solar power system that can meet wide variety of electrical needs, no matter how large or small. Now we have to see power and energy output. Power available from a solar panel is specified either as a peak power or average power produced during one day. The energy is expressed as a watt hour. This indicates the amount of energy produced during a certain period of time. Now we will discuss how you can classify any photovoltaic system. Photovoltaic power systems are generally classified according to the functional and operational requirement, the component configuration, and how these are to be connected to other power sources and electrical load. So the two principal classifications are grid connected or utility interactive PV system, and second one is stand-alone PV system. Photovoltaic system can be designed to provide DC and or AC power applications, can operate interconnected with or independent of the utility grid, and can be connected with other energy sources and energy storage systems. So now we will discuss what is a grid connected PV system. A grid connected PV system, as shown in the figure, the primary component of such a system is an inverter. It is also called power conditioning unit, that is PCU. So the power conditioning unit converts DC power produced by photovoltaic array into AC electricity of the same quality that comes from the power grid. Any energy that is not used is fed back into the power grid for others to use. So here you can see the schematic diagram of grid connected PV system. So in first block you can see it is a PV array. So as I already told you that PV array is nothing but it is interconnection of different PV modules. So as solar radiation incident on the PV array, so it will convert solar radiation into electricity, and whatever the power or electrical supply you are extracting from PV array, it is DC, or you can say direct current. That means nature of supply is DC, because in any domestic purpose or household, whatever the power we are using, that is a AC supply. That means what you need to do, you need to convert DC electrical power generated from PV module into AC, and it can be converted with help of inverter, or you can say PCU. Now this supply that is coming from inverter is AC is given to the distribution system, and from the distribution system this electrical power can be used for the household purpose, because it is a power, that power you are getting is a AC load. So whatever the electrical load you are using in your home, like ceiling fan, any refrigerator, mixer, TV, all are the electrical load, and same electrical power can be used for any electrical utility. So this is a very simple schematic diagram of grid connected PV system. So the PCU automatically stops supplying power to the grid when the utility grid is not energized. During off sunshine hour and during other periods, when the electrical loads are greater than the PV system output, the balance of power required by the load is received from the electric utility. This safety feature is required in all grid-connected PV system and ensures that PV system will not continue to operate and feed back onto the utility grid when the grid is down for service or repair. Now we have to understand standalone PV system. As name is indicating, standalone PV system are designed to operate independent of the electric utility grid. That means there is no grid in the picture when you are using standalone PV system. Such systems are sized to supply certain DC or AC electrical load. This type of system may be powered by a PV array only or may use biomass or biogas based power generation system also. Such type of system are called PV hybrid system. The simplest type of standalone PV system is shown in the figure. Here you can see such a system operates during sunlight hours only because you are not storing any electricity in the battery. So whatever the electricity you are generating with the PV array, directly it is transferred to the DC load. So where you are using, like you can use any DC load, you can use any DC fan, you can use any solar lantern for such system. So this is the simplest type of standalone PV system from where directly generated electricity from the PV array can be used as a DC load. In many standalone PV system, batteries are used for energy storage. So figure shows a diagram of typical standalone PV system powering DC and AC loads. So here you can see the standalone PV system with battery storage powering DC and AC load. So here you can see, first of all, whatever the power is generated from the PV array, it is being transferred to the charge controller, and from the charge controller the power is transferred to the DC load, and at the same time you can store the power in the battery. That means whatever the electrical power you are using, that is a DC, because battery can store the DC power only. Now suppose if you want to use this stored electricity in off sunshine hour, that means suppose you want to use in the during night hours, that means, and you want to use as a AC load. So what you need to do, you need to convert this DC electrical power into AC. And how you can convert this DC into AC? It can be converted with the help of the inverter. So now we have to understand what is the function of charge controller. A solar charge controller is fundamentally a voltage or current controller to charge the battery and keep electric cells from overcharging. It directs the voltage and current hailing from the solar panel setting off to electric cells. Generally, 12-volt board or panel put out in the ballpark of 16 to 20 volt, or if there is no regulation, the electric cells will damage from overcharging. Generally, electric storage device required around 14 to 14.5 volt to get completely charged. The solar charge controller are available in all features, cost and sizes. The range of charge controller is from 4.5 ampere and up to 60 to 80 ampere. Types of the solar charge controller. So basically there are three types of solar charge controller. They are simple 1 or 2 stage control. Second one is PWM, that is called pulse width modulated charge controller. And third one is maximum power point tracking, or you can say MPPT charge controller. So first one is simple 1 or 2 controls. It has shunt transistor to control the voltage in 1 or 2 steps. This controller basically just sorts the solar panel when a certain voltage is arrived at. The main genuine fuel for keeping such a notorious reputation is their unwavering quality. They have so not many segments, there is very little to break. Second type of charge controller is PWM, or you can say pulse width modulated. This is the traditional type charge controller, for instance blue sky and so on. These are essentially the industry standard now. Third type of charge controller is maximum power point tracking. The MPPT solar charge controller is the sparking star of today's solar system. This controller truly identifies the best working voltage and amperage of the solar panel, exhibit and match that with the electric cell bank. The outcome is extra 10 to 30% more power out of your sun-oriented cluster versus a PWM controller. It is usually worth the speculation for any solar electric system over 200 watt. Now we have to understand how charge controller function. The most essential charge controller basically controls the device voltage and opens the circuit, halting the charging when the battery voltage ascends to a certain level. More charge controllers utilize a mechanical relay to open or shut the circuit, halting or beginning power hailing of the electric storage device. Generally, solar power system utilize 12 volt of batteries. Solar panel can convey much more voltage than is obliged to charge the battery. The charge voltage could be kept at the best level while the time needed to completely charge the electric storage device is lessened. This permits the solar system to work optimally constantly. By running higher voltage in wires from the solar panel to the charge controller, power dissipation in the wire is diminished fundamentally. The solar charge controller can also control the reverse power flow. The charge controllers can distinguish when no power is originating from the solar panel and open the circuit separating the solar panel from the battery devices and halting the reverse current flow. So in brief, we can understand the key function of the charge controller are protecting the battery from overcharging by limiting the charging voltage. Second key function of charge controller is protecting the battery from deep and or unwanted discharging. Third one is preventing the reverse current through PV modules at night. And last key function of charge controller is providing the information about battery state of charge. So here you can also see the typical hybrid PV system. That means in first block you can see the PV array. Output of PV array is given to the charge controller, and from the charge controller the power can be transferred or it can be used directly as a DC load. And if you want to store this electrical output of this PV array, it can be stored in the battery in form of a DC. And because we are talking about the hybrid PV system, that means there is a two type of source. One source is solar PV system and another is engine generator, or it can be used by the PV, by the wind system also. So suppose you are generating any power from the engine generator, so it can be transferred to the rectifier, and with the help of the rectifier it can convert AC into DC, so you can store in the battery. Similarly, if you want to use directly the output of electric engine generator, so it can be transferred to the AC load. So there is a two way to use this hybrid system. If you want to use as a AC load, that means if you are using as a AC load, so power can be transferred from PV array to the charge controller, then it can be stored to the battery, and then output of battery can be converted into AC with help of the inverter. Or directly you can take the AC load from the generator. So hybrid PV system is, it is a mixing of two type of sources or more than two type of sources. One source is a PV array, another source is engine generator, another source may be the wind system or maybe the biogas or biomass also. Again here you can see what is the hybrid PV system. Directly output is given from photovoltaic to the charge controller, then it is transferred to the DC load. And again here you can see different source, like you can use the DC generator, you can use the windmill, or you can also use the any grid connected system. If you want to store, that means you need to convert AC into DC, it can be converted with the help of the rectifier. Or if you want to use directly from the generator or windmill or from any grid connected, it can be directly use the AC system. Again, if you want to convert battery for the AC load, that means you need to convert DC into AC, so it can be converted with the help of the inverter. So dear learner, in this particular session we have discussed sizing of the photovoltaic system. That means in briefly we have discussed how you can decide the size of the photovoltaic system. Then we have briefly discussed what is a photovoltaic cell, modules and array. And after that we have also classified the different type of PV system, like grid connected or utility interactive PV system, standalone PV system and hybrid PV system. I hope you must understood all the topic related to the above topics. Thank you very much.